All right, so today we're going to be talking about the structure of the atom. So as you may recall, the atom is made up of three main parts. We have the proton, the neutron, and the electron. We will find our protons in the nucleus as well as our neutrons, while our electrons make up the cloud surrounding the nucleus. Remember, when you're looking at this image, that this is just a gross representation of the atom. The electrons are actually flying around in a cloud where you can't predict exactly where each one is at any given point in time. So as a reminder, protons are positive, neutrons are neutral, which means they have no charge, and electrons are negative. In terms of relative mass, so meaning compared to each other, protons and neutrons are about the same size, so they have a relative mass of 1, whereas comparatively speaking, electrons are so tiny that we consider them to not have any mass at all. When we're looking at our atoms, it's important to understand the atomic number and the atomic symbol because those help us understand what each element is made of, or what each atom is made of, what stuff it's making up. So the first one is the atomic number. This represents the number of protons in an atom. Every single atom of so if I have hydrogen, every single hydrogen atom will always have only one proton. If you gain another proton, so if I now have 2 protons, now I'm helium. If you change the number of protons in an atom, you've changed what kind of element that atom is. And it's going to also, our atomic number will also represent the number of electrons in a neutral atom. So in a neutral atom of helium, for example, we will have 2 protons and 2 electrons. The atomic symbol, on the other hand, is a letter or 2 that represents the element. The first letter is always capitalized and the second letter is always lowercase if there is a second letter. If you have something where you see 2 capital letters next to each other, that means that you have 2 different elements there. Diving a little deeper, atomic mass. Atomic mass is the mass of an individual atom. So we're not going to measure this in grams because that would be so tiny it would be practically impossible. But what we do instead is we measure it in atomic mass units. So remember how we said that a proton weighs 1 and a neutron weighs 1? Well, if we have 1 proton, that's 1 atomic mass unit. When we calculate our mass for an atom, we're going to base that on the number of protons and the number of neutrons. So our atomic mass will be the total number of protons plus our total number of neutrons. And in order to calculate the number of neutrons, since we know the number of protons, we would take the mass as it is on the periodic table, rounded to the nearest whole number, minus the number of protons. Isotopes are when we have atoms of the same element with different number of neutrons. Basically, if we change our number of protons, we've changed what we're made of, right? But if we keep the same number of protons but change our number of neutrons, we've changed our mass, but we're still whatever that element is. We call these guys isotopes, and generally one of the isotopes is going to be more common than the others. So for example, carbon-12 is the most common that we have right now. However, you'll find some carbon-13 and carbon-14 out there. Isotopes tend to, although they're not always, but they do tend to be radioactive. Let's take another look at our carbon example. If you look over there at carbon, carbon-12 has 6 protons and 6 neutrons. So if a proton weighs 1 and a neutron weighs 1, 6 plus 6, that gives you 12 as your atomic mass. When we go up to carbon-13, that 13 means that we have a mass of 13. So 13 minus our 6 protons, because remember, we haven't changed our number of protons, minus our 6 protons gives us 7 neutrons. And if we go all the way up to carbon-14, that means that now we're dealing with 8 neutrons.